So you've got the cross-sectional area multiplied by the height. For our volume and our area is the two circles plus the circumference multiplied by the height. And there are two equations. Like we know with these problems, we're going to get two equations. We're going to have to remove a variable. Which one are we going to use to do that? Well, we know the volume of the can is 500. So we're going to have to use this equation to get rid of a variable and ask myself, what variable looks the easiest to get by itself? H. H equals 500 over pi r squared. Call that 1, call that 2. So 1 into 2. And I should have A equals 2 pi r squared plus 2 pi r h, where h now equals 500 over pi r squared. Can I do anything with that?
You can get the pi's done.
I can get rid of these pi's, can't I? Anything else? I can get rid of this r and that power. So if I rewrite this equation for area, I should have 2 pi r squared plus 1000 over r. What do I do with that now?
How did you get rid of that one?
This r?
Yeah.
R divided by r squared is just r. Yes, Ethan.
You put the 100 and r squared on the other side, so then you can times it back.
I will once I do something else. You're talking one step in front, which is good. You're right. I know you're right because you said r squared, which is good. So, the 1000 and the r squared. But before we do that, we have to derive it. And that equals 4 pi r minus, do I have to do this slowly or not?
Yes.
Okay, that's a good point. I should do it slowly. That's r to the negative 1, isn't it? Yep, so if I derive that, I multiply the power down, so it should be plus 1000 times negative 1 times r to the negative 2, which I can write as 4 pi r minus 1000 over r squared. And then exactly what Ethan said, well before I do that, what's this got to equal? 0. Exactly what Ethan said, where I add 1000 over r squared to both sides. If you want to let my year 12s know how to do this, that'd be much appreciated. And the reason I do that, Ethan, is to do what?
Why didn't you just?
Okay, sorry, I thought Ethan knew what we were doing.
Why didn't you just take the pi away on that 2 pi r plus pi 2 pi r? Why did you take away the square? Why did you not just leave the square?
Because I've got, this is essentially like saying 2 pi r times 500
But couldn't you like
over pi r squared.
Couldn't you like skip like 40 lines of working?
I could, but if I did that, people would get really confused.
Oh, okay. That's what I did. I was like, you're gonna have to take it away later anyway. So.
Once we get to this point here, I've got r's on both sides. I want to get r's to one side. How do I get rid of the r's on the left-hand side? Because they're in the denominator, I want to get them to the numerator. So what do I do? Yeah, well, how do I get rid of a divide r squared? I multiply both sides by r squared, correct? So my next line should have 1000 equals 4 pi r times r squared. Can I write that any more efficiently? 4 pi r cubed. What should I do now? Divide by 4 pi. I'm going to come over here because I'm running in the room. 1000 over 4 pi equals r cubed. I can write that a little bit more efficiently, can't I? 1000 over 4 is? 250 over pi, and I can write that as the cube root of that equals r. The radius equals 4.3 what? Centimeters. How do I know it's centimeters?
4.3 meters radius.
How do I know it's centimeters? The can was 500 cubic centimeters.
Would we add 3 there?
Hmm?
Or that's what we put. You put it as cube.
No, that one's 4.3 centimeters. Yeah.
Why not?
Because radius is a length. So a length times length times length gives us the volume. Yep. Am I done? What are the question asks? Find the height. So very good. So it's I'll call this 3 sub 3 into 1. Sweet. It is interesting that your increased intelligence aligns with an increase in motor.
So that battery